based on some census data. So typical household income in 1980. Let's see, what the hell was I doing in 1980? I was in middle school. All right. Nope, I was in fifth grade, sixth grade, one of those. I had $125,000. Okay, typical high income. Similar household in 2009, so quite a bit later, earned $180,000. So what was the relative increase for these households from 1980 to 2009? See if you can whip that out on your calculator. See if we agree with one another. And we want to round to the nearest percent. So write something down, give it a calculation. All right, anybody have what they think the percent is? $69, not 69. Nope. Nope.
43.
43 is correct. So let's look at it a couple of different ways. So first thing we want to do is we just want to find the difference between those two numbers, find the absolute change. So the absolute change, I got 54,445. Once I get the absolute change, then I can divide that by the base amount. Which one's the base amount?
The smaller one.
The smaller one in this case, because it's the earlier in time. So earlier in time was the 125,556. When I divide those two, I get 43% roughly when I multiply that by 100. Okay, so that's one way to do it. Now, notice that 0.433363. Another way to look at it is if you just take the new amount and divide by the old amount, you'll get a similar answer. Notice what this one says, 1.43363. Right? So the only difference between the two numbers I just calculated is that one in front. So the question is, does anybody remember I talked about this before? What does that one in front mean? What's that related to? So I'll write down those two different ways I got it, and we'll try figuring that out. So first way to look at it is find the absolute change. And that's where I take the new amount. Let's work it out. For the new amount, 181 minus 125,556. And then I get, that was what, 54,445 for the change. To get the percent change or relative change, I just divide those two. So I take the 54, the absolute change, and divide by the original amount where we started, 125,556. And that came out to about 43%. An alternative way to look at it is to not worry about the subtraction. Just take the new amount divided by the old amount. So that would be the 180 divided by the base amount, 125,556. When I do that, I get 1.43 as a decimal, which is 143%. So my question then is, what's the 100 have to do with 100%? 100% of what? What is that?
I don't know.
Just take a guess.
I'm just saying, if you were gonna go over there, back over to that thing, and then you just canceled out the 2 1s, you'd end up with, wouldn't you end up with 43%? Because they're the same, like you cancel out zeros. Go.
It's 100% of the 125,000, isn't it?
Yeah, it's the base amount, because here I didn't take the 125,000 away, so that's what the 100 is. The base amount is always 100%. That's what you started with. From there, it went up, right? So this number right here represents the original amount plus 43% more. That's that 54,000, that 43% more. So there's a couple of ways to look at it. Now, if we do the division in reverse, that just tells us how to look back in time. So here we're looking forward in time. From 1980 up to 2009, we increased, right? If we look back in time, people made less, right? How much less? Well, they made 54,000 less, which is about 43% is the increase. The decrease goes the other way. So did anyone divide those numbers in the other direction? What if I take the 125,556 divided by 180,000? So I think that might be the number Kristen came up with. So this is letting the base be 2009 and then going back in time. So people back in 1980 made about 70% of what people made in 2009. Or you could say they made about 30% less than we do now. So it depends on what you choose your base amount to be. So when we look at that absolute change, a new page here. So let's see, we started in 1980 with an amount of 125,556.
Would those numbers be that far off?
You'll see. In, let's see, what was it, 2009, is that where we jumped to? That was 180,001. To get from here to here, in looking at it, you know, as an increasing, we had to go up 54,000, oops, it's not a 4. $54,445. You could also say, if you go this direction, people made less. How much less? Well, 54,445. I mean, it's the same dollar amount. When you look at the relative change going in this direction, you have to take the 54,000 and divide by the original amount, 125. That turns out to be about 43% when you go that way. However, if you try to look back in time, then you're switching your reference point. This is now my reference point. So now I have 54,445. Instead of dividing by the smaller number, I'm dividing by the bigger number. So it makes the percent change look small. And that came out to be what, like 31%, 30%, something like that. So that's a drop by 30% from a bigger number. Here, 54,000 is an increase by 43%. The problem is we just changed the denominators. So percent change is a little tricky because it depends, well, what number are you comparing to? Okay. So if we forget about time for a minute and we're just comparing two people, one person makes 125,000, the other person makes 180,000. Bottom line is they're different by about 54,000, right? Okay. Now, the person that makes more money, they make 43% more than the person that makes less. Or the person that makes less, you could say, they make 30% less than the person that makes more. The bottom line is you're changing the denominator.
It should be the same.
Well, the dollar amount is the same. This goes back to that whole percent women smokers thing.
Yeah.
It's the same question as the women smokers, right? What percent of women smoke? What percent of smokers are women? When you change the question, you change the denominator, so the percent looks different. It's the same group of women. We haven't changed that. We're just changing who that we're comparing to, right? So a percent change is a comparison by division. If you change the direction of the comparison, you change the denominator. You change the denominator, that's got to change the percent because you're looking in a different direction. Okay. So another place this comes up a lot in businesses, percent markup. So let's take a look at this. This is an important idea. So there's two ways of looking at percent markup when you run a business. One way is you buy stuff wholesale, right? Okay. And then I mark it up from there. So if I buy something for $1 in my store, am I going to sell it to you for $1? No, I want to make money on it, right? So I'm going to mark it up somehow. So Cole, what should our percent markup be? 30%? Let's make a little more. How about 50? Okay. How about 100, 400? Yeah, I mean, it depends on the object. Like, if you think about a pen, those are probably marked up like 500%, maybe more. But other items like a book, that's probably only like a 10 to 20 to 30% markup. So there's different markups on different items usually. But let's suppose we're going to do all the same thing. So we're going to go up by 50%. So if I buy something for, let's keep it easy, $1 wholesale, then the retail price is going to be 50% more than that. Well, 50% of $1 is 50 cents, so that means I'm going to retail it for $1.50. Here's the original dollar I paid, plus I'm going to make 50 cents when somebody buys it. So if I'm ticketing items, I need to consider percent markup based on the wholesale cost. Okay, so that's what we have here. Percent markup based on cost. Now, however, there's another part to my business, right? So I buy stuff and I got to sell it. At the end of the day, at the end of the week, I got to figure out, well, how much did I make this week? Because I got to pay employees, I got to pay utilities, and then I got to figure out how much I made and how much I'm going to put away, to keep the business going. So I'm also concerned about my profit. So what's profit? Well, profit is just equal to your revenue minus your cost.
There's a lot of variables in that. Like rent.
Oh yeah. So I'm going to ignore, right? I'm going to for cost. I'm just going to talk about the cost of the item. But right, in reality, I've got rent, I got employees, I got taxes, I got insurance, utilities, tons of stuff. Right, but just like keep it real simple. So as far as cost for me, I'm just going to look at wholesale cost of the item, and revenue is just what people paid. So with just this simple idea right here, well, my revenue was $1.50. I sold one pen. It cost me $1, and so my revenue, let's put it over here, is 50 cents. So let's compare the 50% to our revenue, though. So 50 cents divided by $1.50. What about your calculators? What is that? As a percentage.
0.33.
Yeah, 0.33. So we'll go 33% about. So it's about 33%. It's 1/3. So I'm going to sell more than one pen, I hope. I'm going to sell a whole bunch of stuff. If I marked everything up based on that, 50% idea, that's 50% based on the wholesale, right? Based on the cost. Here, that 33%, is that based on cost? Is this number cost right there? What's the $1.50 represent? It's not cost, it's what? It's revenue, yeah. This is percent markup based on revenue. So percent markup based on revenue. This is useful because at the end of the day, at the end of the week, if I look at how much money is in my till, how much did I take in, right? That's revenue. If I want to figure out what part of that is profit, I just take 33% of it, and that's my profit. The rest has to cover my costs. Okay. So that's a useful number too. Both are based on this 50 cents right here. I just changed the denominator. So this version is useful in the retail business because when you look at how much money you took in that week, you take 33% of it, that tells you what you made after your costs, assuming simple cost, right? We're only talking about wholesale costs. On the other way, this one is useful when I'm putting items on the shelf because I got to figure out what I'm going to charge people. So two different perspectives. So if you go to a business and you ask them what your percent markup is, which of these numbers are they going to tell you? It depends on who you ask, right? If you ask the person in the business that does most of the ticketing, or that's what they were just doing, they're going to say, "Oh, we mark up 50% is our average markup," you know. But if you're talking to somebody who's running the cash register and has to clean all that up at the end of the day, they're going to say 33% because that's based on the end of the day money they have. Is either one a misrepresentation of reality? No, they're just two different views of the reality, depending on which direction you're going in. But we're talking about the same 50 cents for every dollar that we bought something in, or 50 cents for every $1.50 we sold. Okay, it's the same amount. It just depends on the direction we change the denominator. So that's the same idea. It's the same math as the women smokers who are women, as looking forward in time and backward in time in terms of those incomes. Same idea.
Some businesses keep really good track of this, like McDonald's, for instance. That's everything that sells. It has the breakdown of like each piece of cheese and pickle and whatever kind of cost.
Oh, it's super detailed in terms of the inventory.
And it does it automatically in the computer.
Yeah.
And like at the end of the day, you count up all the waste that you have, and then you punch that in. So each patty and everything is calculated down to the cents what your waste was.
Yeah. Yeah, that franchise, McDonald's, has built that system, and there's a lot of other franchises that have really good systems like that. For smaller companies, you can buy software that does all that for you. You plug in your inventory, you plug in markup for different kinds of things, and it just works it in either direction depending on what you're doing. But it's good for us to know what the software is doing and not just be slaves to whatever that computer tells us. All right, so that was exciting. All right, so this is important. We spent the last couple lessons on it. We're going to shift gears just a little bit and look at this change stuff graphically. So finish up your homework 2.6. If you have any questions on it tomorrow, let me know. Let's see. If you didn't finish the spreadsheet on both the South Atlantic and Mountain States, get that done, because then you want to upload it into the lesson here. So if you're a Google Sheet person, then you send me your share link in here. If you're an Excel person, you'll upload it. 3 people uploaded it so far. I wanted, for the questions, you only had to do 1, but for the spreadsheet, I wanted you to do both just to get practice doing it. So if you did 1, go back and do the other. And you can upload more than 1 file. You can put more than 1 text entry in. So Google Sheet users, put your link here to your sheet, the share link. Excel users, put your file here once you got that. And then pretty much every lesson till the end of the term is going to have an upload. So we'll probably do some work in the lab tomorrow. Robert, do you have a question?
No, I'm just trying to remember. I think they told me to do both when I did it. So
yeah, I know you uploaded something. I haven't had a chance to look at the uploads yet. So if somebody's missing one, I'll let you know and I'll ask you to re-upload it. Okay, so let's take a look at 2.7. And we'll just scratch the surface of it today and work on it all class tomorrow. 2.7. Grab one of these, pass around, and grab 2 of these, pass around. All right, so graph paper, there's graphs on the worksheet, so you can just draw on there, but some extra graph paper might be handy for this. In our next class, I'm going to show you how to have a spreadsheet make a graph for you. I don't think we've got spreadsheet made. Have we done any spreadsheet graphs yet? I don't think so. No. Yeah, we'll do a spreadsheet graph tomorrow based on some stuff in the worksheet. So when we graph something in some relationship between numbers, generally we have two different axes. We have a vertical axis and we have a horizontal axis. Sometimes they're given boring names like y and x. Sometimes it's more exciting than that.
One of those at least on this graph paper.
All right, so basically two number lines stuck together there. So to find a point, we usually state the horizontal variable first and then the vertical variable second. So 2, 3 means go right 2 and up 3. All right, let's jump down to the more exciting stuff over here. So what we want to do is consider the change in population of Washington. Okay, so in 2000, U.S. Census is about 5,900,000. 2010, it was about 6,700,000. Okay, so we can calculate an absolute change, and we can calculate a relative change for those. So we'll do that shortly. But let's go look at the graph here. So do you think the population went up nice and smooth from 2000 to 2010, or did it maybe jump around a little bit? Did it go up more some years than others? Okay. So what I want you to do is draw one possible way of how the population changed from 2000 to 2010 and then continue through 2020. And I want you to do that in a couple of different ways. So right now I'm going to give it a try. And I'd like you to try too. How could the population have changed? So one possibility, it went in a relatively straight line, and it's going to keep going like that. So here's my original points there. But maybe they had some kind of boom, and then it kind of leveled out for a while, and then it started going up again. And who knows what's going to happen after that. So there's another possible way it could have happened. Maybe it just stayed kind of straight for a while and then just took off for some reason, and it's going to keep going nuts. Huge population increase. So there's lots of possible ways the future can go from one point to another in terms of change. So write down a few different ways through that graph of how we could go from 2000 to 2010 and beyond. And if you don't have different colors, you could do dashed and dotted and solid lines. There's lots of possible things that could happen here. So what we're going to do in the next class is we're going to play around with graphing on a computer by giving the computer tables of numbers. The computer can plot the points really easy, Excel or Google Sheets. And we'll look at the difference between what does it mean to graph using absolute change, what does it mean to graph using relative change? So we're going to try both of those methods too and see what happens. So we're done for today. Catch up on your homework if you've fallen behind. The term is almost near. We got 3/5 of a week this week, a full week next week, and then finals week. All right. So have a great
We don't
day.
have finals. We got one little stretch on Monday morning.
That's all you have?
No.
Oh, for us, yeah, for finals week, we only have one class, yeah.